Okay, this is an overview of regression. Regression is a huge topic. This class will only talk about basically linear regression, but you could take a whole course. And actually, I have taught a whole course just on different regression techniques, but that's a topic for another day. So this is just going to be an overview of regression. The most basic form of regression is based upon linear regression, that there's this linear or monotonic straight line relationship. So it's represented by this basic equation, which you actually might be familiar with from high school algebra. So y, meaning the dependent variable, is equals b or beta multiplied by x, which is your independent value, plus a, which is the intercept. A and b are fixed constants that you will derive from your analyses. So it'll be b multiplied by x, whatever x value you have for your independent variable, plus a will indicate your dependent variable, where b is slope and a is intercept. Regression basically refers to the technique of finding the best fitting line for a data set. So the result of regression line is based upon a linear relationship. So the y hat is otherwise known as your, that's the y hat here. Your predicted y value is b multiplied by x plus a. So this is based upon ordinary least squares regression, which is very basic form of regression, where we find the distance between predicted y and actual y. So the distance of y minus predicted y, or y hat. The calculation of gives you a regression line, otherwise known as the line of best fit. And basically for your data points of x values, your independent values in your y values, what is the best fitting line of the scatter plot of data points. So first step is to find b. And b is a function of or equals the sum of products divided by the sums of square for x. Alternatively, you can find b, which equals r, your r value, the correlation, multiplied by standard deviation of y over the standard deviation of x. Then we find our a. A is the mean of y, or the dependent variable, minus b multiplied by the mean of x, or the independent variable. Now, we should quickly review the sum of product calculation. The definitional formula for sum of products is sum of products equals the summation of x minus m sub x multiplied by y minus m sub y, where m's are the means. The computational formula, which is the one you'll want to use, is the summation of x, y, or the product of x and y, summation minus summation of x multiplied by the summation of y divided by n. So we also need to test the significance in a regression, aka the analysis of regression similar to ANOVA. And in this testing of the significance of a regression line, we say H sub O, regression equation line, or our null hypothesis, regression equation line, accounts for a significant amount of variance in y greater than chance alone. First, we calculate what is explained by our regression equation. So predicted variability, or so sums of square regression, is r squared multiplied by sums of square for y. Second, we calculate what is unexplained, or the unpredicted variability, which is the sums of square residual equals 1 minus r squared multiplied by the sums of square of y. Both have accompanying degrees of freedom. Degrees of freedom for the regression is 1, and the degrees of freedom for the residual is n minus 2. Uh-oh, That kind of creeped up. Third, we calculate the mean square regression, the mean square residuals. The mean square regression is sums of square regression over degrees of freedom for the regression, and mean square residuals equals the sums of square for residuals over the degrees of freedom for residuals. Fourth step, we calculate our F ratio, which is the mean square regression over the mean square residuals. This is very similar to the ANOVA process, where degrees of freedom equals 1 and n minus 2. Then we also need to be cognizant of the standard error of the estimate, which measures the standard deviation between a regression line and the data points. The calculation for this is simple. It's the sum square of the residuals divided by the n minus 2 square root, or conversely stated, it's the square root of the mean square residuals. In general, if the correlation is small, the standard error will be large. So, one last thing. R squared is otherwise known as the coefficient of determination. It will tell you how well your regression line fits. So you can test the significance of the regression line. It'll tell you, well, is that line significantly better than chance? But you want to know how good it is. So the measure of effect size here of how good it is will be an R squared. So it measures the variability in one variable that can be determined by its relationship in another variable. So an R value of 0.80 corresponds to an R squared value of 0.64. That's saying that 64% of the variance in Y, or the dependent variable, may be accounted for by variance in by the independent variable. Okay, so I stated again, 64% of the variability in Y can be explained by X. Okay, well, thank you, and that was an overview of regression. It's a huge topic, though. Thanks.